Department, Thakur College of Engineering and Technology, Mumbai. This is a day 4 afternoon session of Labview Programming and Hardware Interface (FDP), and today's topic is interfacing of embedded system with Labview. And today's speaker is Dr. Arpit Ravankar sir. So now I request Arpit sir, please start your session. Over to you, sir.
Okay, thank you, sir. Thank you very much.
Welcome, sir.
Very good afternoon to all the participants. So we will start the session. I will start sharing my screen. Okay, so I hope my screen is visible.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so see that we have seen that how we can interface a particular hardware with the Labview. Now, this particular session, I wanted to take a data acquisition process, and as well as acquiring the data, modifying the data, all those sorts of things I wanted to consider. Okay, so like couple of times I was asked a question that can we really save a data from a particular hardware? Suppose I am having a temperature sensor, I'm having some communication channel, I'm having some signal, and I want to plot. I was able to successfully plot it on my Labview software, but I also want to keep a record of that data. Okay, so mostly the data are like, if it's a numerical, then it's being stored in an Excel file. If it's a text, then we saved it in a text file. So like that, different formats are there. So in this particular case, this particular section doesn't require any hardware. Now whatever session I am taking now for these 2 hours doesn't require any hardware. We will generate a data and we will try to put it in an Excel sheet. Okay, so press Control E. So once we press Control E, we switch to a block diagram. Now press right click over there, and there is a file IO. Okay, there is a file IO. Where you find the file IO? Just near the timing. Okay, so it's a 4th row, 1st column. You find a file IO. Okay. So in the file IO means input and output. So either you can take an input data or you can give an output from these files. So these Labview provides the facility of these files. You see that the first one is a write delimited spreadsheet, write and read. This 2 is a spreadsheet. Spreadsheet means Excel. Okay, write to an Excel, read from an Excel. Then write a measurement file and read a measurement file. Okay. See here, there's a write text file and read a text file. So जहां पर भी आप देखेंगे, जहां पे एक पेन बना हुआ है, पेंसिल बना हुआ है, that's a write. Okay, और जहां पे एक चश्मा है, there is a specs, that is a read. So here there is a specs, this is a read. So just by looking at the library icon, we can determine whether it's a read and write. Okay. Then apart from that, there's open, create, close, format, scan. Okay, vform file IO. Write to a file, read waveform, export a spreadsheet files. You can make a zip files. Okay. So zip files means you see that here we can have collections of the data. Automatically we can create a zip file. Then Apart from that, there is a binary files also, write and read binary files. So files, the data that are like you take a data from any sensor or from a communication channel. So basically, a data is in the terms of ones and zeros. So that ones and zeros binary file reading and writing, we can do. Okay. So one by one, I will explain the functioning. Okay. So let's start with the text. Okay. So go to file IO. Go to file IO. Then let's start with a text. So write a text file. Write a text file. Just drag and drop, put it over here. Okay. Write to a text file. Now see its property with the question mark. What does it do? See, that takes a text. Text has a pink color. Okay. Text wire is a pink color. So this basically it's a string. And you see that there is a file path, a green color file path is given. Okay. So write to a text file means I have something written in my program. That particular thing I want to write to a particular file. Okay. So press Ctrl E. Okay. Now create a input string. Right click, go to string and path. First row, third column, string and path. So this is in the string and path, this is the string control. Now take the string control, put it over here. Okay, you can type anything. Okay. So I have given one message that welcome to Thakur College of Engineering and Technology, Mumbai. It's heavy raining here. Okay. So some message I have written. Now I want this message to be written to a file that is a text file. Okay. So this particular message, I want this particular message to be written to a particular text file. So which file that we need to decide? Okay. So one thing I can do, go to your now go to your desktop. Okay, somewhere C drive, D drive, anywhere you can go. I will go to my desktop. See, this is my desktop. Okay. Now right click, create, go to new and create a text file. This is a text document. Don't create a Word file. Okay. The Word file format is different and a text file format is different. We are writing a text. Okay. Not writing a Word document. And then text letter can be converted to Word. So create a text document anywhere in C drive, D drive, whichever drive you want to use. I will create one text document on the desktop. So this text document is created over here, new text document. Let me give some name. So today is 28 June 2023. A text. Okay, some file I have created here. 28 June 2023 text file. This file is being created. Now see, if I open it, it's completely blank. There is nothing. 28 June 2023 text file is completely blank. I want something to be written in this particular file. I close this file. Okay, now I move to my program. So see that creation of file is done. Creation of one file is done. Okay. Now, how you will decide? How you will decide that you have to give a location for a particular file that is to be written. So right click, go to string and path. Okay, so everything we find in the string and path. In the string and path, select a file path control. Okay, so string and path mein jaiye and select a file path control. Just select it here. So just like a file path, we can give from this particular path. Okay, which path you want to give? Right click, just click here, left click. इस पे लेफ्ट क्लिक कीजिए. मैंने डेस्कटॉप पे टेक्स्ट फाइल बनाया. द डेट इज 28 June 2023 text. This text file, a complete blank file I have created on desktop. I press OK. So see that now it's showing the C users Arpit desktop 28 June 2023 text.txt. So one file is created over here. Okay, so this shows the path, and here it shows the text. Okay, so which file? This is the path of this file path, and this is the text. Okay, press Ctrl E. Now front panel, from front panel side, the programming is done. Now this is a string and there is a path. Okay, now see its property. Here on the left there is a path, file path, a green color wire is there. Just connect it to a path. Okay, what about string? There is a text. Just move your string over here and connect it to that text. Anything remaining? No. File path and all these things are not needed. So see, this is done. This is done. There's nothing more to be done. See, there's a write to a text file. We have to write to a particular text file. What we need to write, that is given on this string. What is the string? This is welcome to Thakur College of Engineering and Technology, Mumbai. It's heavy raining here. This is the message. And what is a file path? Where you want this particular text to be written? Yeah, on this path I have mentioned one file. This is the file on my desktop. 28 June 2023 text. This is a blank file I have created. Now that's it. I will run this program. Run, done. Okay, now minimize this program. Check the text file. Now this is a text file, 28 June 2023 text. See that a message, a welcome to Thakur College of Engineering and Technology, Mumbai. It's heavy raining here. That's being reflected as it is. So it's called as writing to a text file. We can write a particular text from a string to a text file. Okay. Now same thing I will do with the reading, and then we'll move to the Excel. Okay. Now what more we can do? I need a certain file, and in that file I will create something. Okay. So I need something to be. Okay, some any message we can just copy paste. Okay, so any message we can type. So just I will copy this message. There's a text file. Okay, so there is some text that is. Okay, so maybe a bit of pay hack for WTC final Ponting, Nazir Hussain telling reaction on India's ODI World Cup opener versus Australia. So some news is there. Okay, now this thing I will save it, file save. Okay, now I want this particular statement to be read and should be displayed on a Labview front panel. Okay, so yeah, so here we go to file IO. Go to file IO. In the file IO, we go to read text file. Now we want to read it. I go to read text file. Okay. Now in the front panel, so I won't be requiring this thing. In the front panel, I will create a file, string and path. Go to string and path, create a file path control. So this is a file path control. Just give a location of this file path. Click here. And we have a 28 June text file. I have given a location over here. Now, whatever written on this has to be reflected on the Labview front panel. So I will create a string indicator. Initially, I have created a string control, but now string indicator. Why string indicator? Because we are reading now. Before that, we were writing. Okay. So before that, we were writing. Press Control E. Okay, now check the properties of read text file. Now see that so it has a one file path control, and on the right there is text. On the right there is a pink color wire, that is text. So that's what we will do. We will connect this file to path, and on the right whatever text is there, we give it to the string control. That's it. Okay, press Control E. Now run this program. See that a complete message has been displayed as it is. Okay, so anything you can type and anything can be reflected. So in the first case, writing means I have written something that I was able to write to a text file. Second, the text file was written or has some data, some text that I was able to read. In both the case, I give a file path. Automatically checks for a file. So that means a report generation is very, very important for the Labview. You can generate any sort of reports. Reports in terms of your numeric data, Excel sheets, text files, okay, digital files. So that's an important part of Labview. Now press just go to file and select a new UI. Now most important part, like all of you wanted to know that, sir, how can we write to a text file, writing to a particular text file, writing to a particular Excel file. Okay, so writing to an Excel file is also possible. Okay, so let's create a program first. Let's create a program first. So I want to have a vform chart. Okay, after that, after having a vform chart, we can create a file path control. Go to string and path and select a file path control. Okay, a file path control I have created, and then this is a vform chart. So any data you can plot, and that data has to be reflected now in the Excel file. Okay, in the Excel file. So press Control E. Now we have these two things. One is a path and one is a vform chart. Okay, a signal has to be created that will be plotted on the vform chart, and that signal as it is will be copied to an Excel sheet that is given in this particular path. Okay, so for that, right click, go to File IO. Once you go to File IO, okay, then on the first row itself, File IO आपको timing के पास में मिलेगा. File IO, first row itself, there's a write measurement and read measurement file. Write measurement and a read measurement file. That means you want to write a measurement file or you want to read from a measurement file. I want to write to a measurement file. I select this write to a measurement file. Okay, automatically one window will pop up. Okay, some window will pop up and it will ask you a file format, which sort of file format you want to. So suppose Labview have most of the text file as a .lvm format. .lvm. Okay, text file के बहुत सारे format होते हैं, उसमें एक format है .lvm. Second is binary. It's a TDMS. Okay, so most of the binary files in the Labview are stored in a TDMS file. So binary files basically all zeros and ones. Okay, so all information in terms of 0 and 1 is being stored in TDMS format. Okay, so this TDMS basically stands for Technical Data Management Streaming. Okay, so Technical Data Management Streaming, and this particular format is only created by National Instruments. So the National Instruments, to make a file library, okay, they have created one particular format, that is a TDMS, Technical Data Management Streaming. Okay, so technical data management streaming files are there. So either you can save it a binary file, so you can have a text file, binary file with an XML header, and see the last one is a Microsoft Excel. Did you see this? You have to check it. It should not be unchecked. Okay, so when you right click on the measurement, write to a measurement file, you must check this Microsoft Excel. Okay, now in this Microsoft Excel, it will ask that one column per channel you want, one column only, you want a empty time column. So it's totally up to you. आपको एक कॉलम का पर चैनल डेटा चाहिए, सिर्फ एक कॉलम चाहिए, या टाइम कॉलम आपको irrespective of the time you want to, just with respect to index number you want to have a data. Okay, so that's it. Now press OK. Now this write to a measurement file, see its property. Okay, अब इसका प्रॉपर्टी आप देखेंगे तो क्या है, इसको एक फाइल नेम पाथ चाहिए. Just drag it from bottom. Don't get confused. Just drag it from the bottom. Okay, so once you drag it from the bottom, then you see there is a file name. In the file name, you can connect the path. Okay, so अभी क्या मतलब रहा है इसका, कि अभी जो भी इस पाथ पे जो फाइल मेंशन है उस पे एक डेटा सेव हो जाएगा. डेटा हैज टू बी गिवन फ्रॉम दिस सिग्नल. नाउ आई रिक्वायर सम सिग्नल, सो आई विल डू सम मैथमेटिकल प्रोग्रामिंग. ओके, सो let's do some programming. Go to structures. Once you go to structures, no, not in the structures, go to here. Signal processing. Go to signal processing. Okay, once you go to signal processing, in that signal processing, go to waveform generation. In the waveform generation, okay, you can select okay, in the waveform generation, you can select any sort of wave that you want to plot. Okay, so let's have a simulate signal. Last one, the simulate signal we can drag and drop. Okay, a simulate signal is there. Now this simulate signal I can give to this waveform chart. Okay, अब ये signal इसमें जाएगा. Then I can give this the same signal to my waveform chart. Okay, so did you understand what I'm doing now? See that this is a simulate signal. साइन सिग्नल मैंने जनरेट किया, उसको वी फॉर्म चार्ट पे प्लॉट किया, उसी का एक सिग्नल मैंने दे दिया राइट टू अ मेजरमेंट फाइल पे, okay, with a particular path. And this program is done to put everything inside a loop. Okay, so now how let's take a for loop to have a fixed number of count. Select a for loop. Now this is a for loop. Give a number of counts to n. Right click, create a constant. Can give a number of counts, let's say 500. Okay, I can give a little bit delay. Go to timing, wait milliseconds. Right click to the wait milliseconds, create a constant, type 100 milliseconds. Okay, let's keep it as a 200 counts. Okay, so we give a for loop के 200 काउंट दिए हमने. ओके, उस for loop के अंदर एक सिमुलेट साइन सिग्नल जनरेट किया, उसको सीधे वी फॉर्म चार्ट से कनेक्ट किया, उसी सिग्नल को राइट टू मेजरमेंट फाइल मेंशन किया, राइट टू मेजरमेंट फाइल में एक पाथ फाइल नेम से कनेक्ट किया, फाइल पाथ कंट्रोल. इस राइट टू मेजरमेंट फाइल को आप डबल क्लिक करेंगे. So make sure you have selected a Microsoft Excel. Microsoft Excel you need to select. Press OK. Press Control E. Okay, now we need to give a path, file path, but I haven't created a Excel file. Okay, so go to desktop. Now minimize this program, go to your desktop. It's not required. Okay. Okay, I go to my desktop, right click, create a new Excel, go to new and select a Microsoft Excel worksheet. Okay, now you can give it a name. Name we can give as 28 June 2023. Okay, TCET. This file is there. 28 June 2023 TCET. Some Excel file is being created over here. Just double click on this file. Try to open this file. Now it shows this file is completely blank. Now whatever data is being generated, that has to be copied and written to this particular blank Excel file. That name is 28 June 2023 TCET. Okay, so I close this file. I know that this file is on my desktop. Press Control E. Sorry, first move to your program. Now this is our program. Let's color this. Okay, now here, select the file which you have mentioned on the file path. Click on this file path. So 28 June TCET is over here. I can find. That's okay. So see that now file format is .xls. So it's in the desktop. See users page desktop 28 June 2023 TCET XLSX. Okay, so file is given. Okay, format is also mentioned. Now in the vform chart, is everything fine? Yeah. Now we can run this program. The program will run for 200 counts and we will see whether we can have the data over there or not. See that a sine signal is being plotted. Okay, so program has stopped now. Okay, this program has stopped. Now see the Excel file that you have created. That was a 28 June TCET. And now you see the data is being stored. Okay, I have given a 200 counts. Okay, so data is being stored. Now just select this data and try to plot this. Okay, so you start getting a sinusoidal signal. Okay, so same sinusoidal signal, you can find what you were getting over here. Both are same. Okay, so like this way we can actually have all our data for n number of iterations. Okay, so the values are also present. These values are available. So this was a writing to an Excel file. You can write to an Excel file as per your wish, your requirement. Okay, so whatever data is there, always do one thing. Just write to a measurement file, double click, select a Microsoft Excel. The data will keep on storing in that Microsoft Excel. Okay, so this is a very important library function, because we always need a data to be stored in some Excel file. Okay, and most of the time we see that here there's a binary TDMS file is there, binary XML header file is there. So right now in my computer I don't have a TDMS reader, or that particular software is not being installed, so I can't create a TDMS file. Okay, even if I can create, I can't actually open it, because suppose like you don't have a Microsoft Excel, your all Excel files will be read in a Word file, maybe as a text document. So that's all you need to understand, that you must have a TDMS, LVM, ये सब फॉर्मेट्स आपके पास रहेंगे, तो आप इन्हें इजीली सेव कर सकते हैं. Okay. So this was a writing. Similarly, you can do a reading from a Excel file. That's also possible. Okay. Now, after Excel and text files, there are binary files and other files. Okay. One more thing I wanted to create now. Let's change this signal. So we'll just delete this. Okay. I will go to signal processing. In this signal processing, I will go to waveform generation. In this waveform generation, I will select this a square waveform. Okay, I will just directly connect this square waveform to this program. Okay, so by default, some amplitude and frequency is given for this square waveform. We don't care about that, and I want to create it. I want this data to be displayed in some files. Okay, now I don't want this delay also. Leave this delay. Okay, now how to store this particular file? Now I don't have any file. Okay, मैंने text जो 28 June 2023 TCET फाइल जो क्रिएट किया वो डेस्कटॉप पे क्रिएट किया था. ओके, आप फाइल पाथ में भी एक नई फाइल क्रिएट कर सकते हैं. कैसे? आई विल शो यू. राइट क्लिक ऑन दिस फाइल पाथ का जो आइकन है उस पर राइट क्लिक कीजिए. ओके, वंस यू राइट क्लिक इट, गो टू द ब्राउजिंग ऑप्शंस. वंस यू गो टू ब्राउजिंग ऑप्शन, नीचे से सेकंड आपको ब्राउजिंग ऑप्शन दिखेगा. In this browsing option, you see that selection mode. There is the files. Okay, I want to select a file, but the file should be existing. That is checked. यानी जो फाइल एग्जिस्ट नहीं कर रही है वो कभी भी राइट नहीं होगी या रीड नहीं होगी. But here you see there is a new and new or existing. So if you select this new or existing, so even if that file is not existing, a complete new file is there, still that will be written and that will be read. Both things are possible. Press OK. So I have selected now new or existing. Press OK. Now I don't have any file. Okay. Now I will do one thing. I will change the name of this file. Okay. Let's because we are plotting a square wave, let's give a name as square wave data. Okay, so I have given one new name, square wave data, and it has to be created on the desktop, and the format is Excel. That's it. No change from here. No change from here. Okay, now run this program. See that on Excel, this square waveform are being plotted up. Here 85, 90, so many iterations are going on. Okay, 149, 155. A square waveform is being plotted up. Program becomes little bit slow once you do a read and write. Automatically it becomes very slow. Okay, 200, it stopped. See that these are the square waves that we plotted. Okay, now let's see whether we have a square wave data file, square wave data Excel created on the front panel, created on the desktop or not. See that a square wave data automatically being created on the desktop. So I double click it and see a lot of data is there. I try to plot it. See, so many data is being plotted. So here you see this is 2 lakh counts, 2 lakh counts. So it depends on number of samples. आप एक सिग्नल के कितने samples ले रहे हैं एक iteration में, that depends on that. So here we have 200 samples and 2 lakhs counts as such. 200 iterations में we obtain so we are having a per iteration we are considering 100 samples. अगर हमने एक iteration में 100 sample consider किया है तो 200 iteration में हमें 2 लाख sample मिल सकते हैं. So that's what this data shows. Now insert chart. Okay. No need to plot everything. You can just take a few of this. You see a square data is being shown on the Excel. So the same square data you obtain over here. Okay, so this is like a plotting to an Excel. Plotting to an Excel as well as writing to an Excel file. इस केस में क्या फर्क था कि square wave data dot Excel file was not at all existing. If this is not at all existing, then there is no chance it can read, but you can actually change the program setting by right click, go to browsing options, and in that browsing option, uncheck this existing and select this new or existing. Once you select this new or existing, it's done. Okay. So this was a writing to a new file. Writing to a new file. Okay. One more thing, whenever you do a program, whenever you write a certain file, you see there is a backup file, a backup to a backup that is being generated. So what does Labview do? अगर आपने कोई सी फाइल जनरेट की है या कोई फाइल क्रिएट की है, उस पर कोई डेटा कॉपी किया है, तो Labview ऑटोमेटिकली उसका बैकअप क्रिएट कर देता है. तो ये देखो स्क्वायर वेव फाइल है, स्क्वायर वेव डेटा, और उसका बैकअप टू ऑटोमेटिकली क्रिएट हो गया आपके डेस्कटॉप पे. सो इट इज लाइक अ you do a writing operation. Okay, you want to have your data copied to Excel because you want to take a backup, but Labview take a backup of that backup. Okay, so it's a good thought that even if that file is deleted, you always have a backup. So always find that how number of write operations you do, a 3, 4, 5 write operations, so then you can have a backup, that 3, 4 backups always. Okay, so next thing, now can I write to a certain file that is already existing? See that here in the browsing option, what we have done, new or existing. अगर existing file है तो उस पे ये copy हो जाएगा. Okay, if it's a new file, then also it is being copied. So it is a writing to a particular file. Now the same data, if I wanted to plot, now let's change this square data. Okay, now just delete this thing and just connect a random number. I have connected a random number instead of a square wave. Okay, what path? Same path I wanted to do. I want to now overwrite that, overwrite. Okay, so what's the options I am having? Go here. Okay, so see that here, आप कहाँ पे click करेंगे? Write to measurement file पे click कीजिए, write to measurement file पे. Okay, once you click on that, see the options over here. If a file already exists, rename the existing file, use next available file name, append to a file, or overwrite a file. You can append to a file, उसके साथ एक और file attach हो सकता है, या overwrite a file. I select a overwrite a file. Suppose I select a overwrite a file, I press OK. Now I know that a square wave data file is already existing. I have a square wave in that. Now I have changed the square wave with a random number. Now let me plot this. See that a random number is being generated. Okay, it will run for 200 iterations. Done. See the file now. A square wave data file is there. See now a random number is being plotted. See that now a square data is changed to a random number. So then like this, you can overwrite to a particular file. You can create a new file. You can overwrite to an existing file. Totally depend on your program setting. So like this, we try to store a lot of data with the date. So see that here. Okay. Press Ctrl E. You click write to measurement file. See that empty time column. You want a time over there. Okay. You can uncheck it. There's a one column per channel. You can select. You can have like a sheet 1, sheet 2, sheet 3. You can have a combination of those files if you append to a file. You can have a next available file name. Suppose I have one file already stored as square wave data. So next file available name is square wave data 1, square wave data 2, square wave data 3, like that. It can rename an existing file. That's also are possible. See that a save to series of files. So then there is a setting, save to series of files. So a date, you want a sequence number, okay? And which sort of file, how many segments are there, everything is here. So file IO is very, very important because it gives us a backup of our data. Whatever we are having in a real time, we can have a backup of data. And the most important, those who are working in a data sciences, they always work on Excel. Okay, so most of the data need to be stored, and in real-time data monitoring, IoT, data sciences, data engineering, we always deal with a lot of real-time data. So then the data can be stored in a binary format. Data can be we can have in an analog format, and we can always play with this particular data. Now see that here, Labview also helps us to make a report. Okay, so just you see that last row, first column, there's a report generation. Okay, report generation is there, and here there's a word specific report is there. Okay, so word easy title, text, word tables, so many tables are there, and see that there's an Excel specific reports are generated. So lot of advanced Excel operations, multiple Excel operations are there. So these particular report generation is for our data science engineers. Okay, so those who wants to do a lot of programming in Excel, they can generate a lots of report for all real-time projects. Okay, for all real hardware projects. So this is what like we do. Like during my research time, when I used to have a I used to have an overnight experiment. So then all my experiments were actually stored in an Excel file, and that Excel file data I used to show to my supervisor. So always it's good to have a backup of data. Okay, so सारे industrial plant monitoring, temperature, pollution, humidity, rain, everything, a report generation is necessary. And once we explore this particular thing, we can have. But actually, report generation requires a one complete workshop. Okay, because you must be a thorough in Excel, you must be thorough in all word commands, and then you can use a Labview platform for our report generation. So this was the one case. Now we have seen a text, we have seen an Excel, the binary files. I don't have a format to read the binary files, so I'm not doing that. Next is a sound file. Can we have a sound file, read and write? Yeah, definitely. We can have a sound file. Now go to file, select a new VI. Now this is a new VI. Okay, press Ctrl E. Okay. Now in the new block diagram, this is a very, very important. Those faculties who are interested in audio signal processing, okay, or a voice signal processing, they must try to use this, because with the least amount of hardware, okay, we can actually do a lot of sound signal processing. Now press Ctrl, just right click, and here you see there's a graphics and sound, a graphics and a sound. So where you will find this graphics sound? First, second, third, fourth, fifth row, second column. Fifth row, second column, graphics and sound there. This particular library will allow the image processing and the voice processing. Okay, so those who are interested in image processing, those who are interested in a voice processing, they widely use these libraries. Okay, but I will show we can actually create a read and write files. Okay, sound files also. See that. Now in the graphics and sound, we go to sound. Okay, so in the graphics and sound, last row में आपको sound दिखेगा. Go to sound. Once you go to sound, see there are files. Simple read file, simple write file, open, intro, read, write, multiple stuffs are there. There's an input, acquire, configure, start, read, stop, clear. Okay, and then there's the output. We play the waveform. Okay, so sound file will be played. This is write, stop, multiple options are there. Okay, So this is input, and we go to files. Because this is a file IO session, I go to graphics and sound. In the sound, graphics and sound में sound पे जाना है, इस sounds में file पे जाना है, and we will do a simple read operation. Just drag and drop, put it over here. Sound file, simple read. Okay, now see its property with the question mark. What does it say? Okay, there is a one path. Okay, we will give a path to a sound file. Okay, position mode, position offset, no, not needed. Number of samples per channel. Okay, path out, data is important. You can give a data. Okay, now I want to give a sound path. So most of your you need to understand that a Labview understands the sound in terms of .lvm. Okay, so any sound file that has to be in a LVM. So see, sound files has a different format, like an MP3 format. Okay, but Labview read and write only .lvm format. It's not that difficult. You can just type. Okay, so .wav converter, WAV converter. You can easily find these free converters. MP3 to .wav converters. Any audio files can be converted to .wav file. Okay. Now try to find out how many, if some .wav files are there. So every PC have some .wav files in that. So there is some home file is there. Apart from that, let me check how many .wav files do I have. Not web result. Okay, so you can have some .wav files. Easily you can find some .wav files. There's a free downloads also. Okay, so just you can type as .wav file download. So you can download multiple sample .wav files. So like here I can download a certain files. Okay, this is stereo .wav files, soft piano. It's 2 minutes 16 seconds, bit larger. These audio files are bit larger, so more than 2 minutes. Okay, this .wav files. Okay, so some files you can easily download. I have certain files in my PC, but you can have these files easy. Okay, now start the programming. Okay, so first I need to create a file format. Okay, before that I will show certain files that my PC is having. So see that yeah. So here I have a certain files, like I have a certain patients files from the hospital. So what we did, I was working on some voice project, okay, voice analysis project, in which we take a samples from our patients. There's a lot of voice data available, and we try to find out a pre-diagnosis of a particular disease. So whether the patient is having a certain disease that we can identify in an early stage. So then we have a certain data related to cancer also. So we have a cancer patients sound files, and these cancer patients were asked to speak a certain vowels like a E, I, O, U, like that. So he can speak like in I as a high tone, I in a low tone. Okay, so I in Hindi and Marathi is pronounced as E. So E is as a high or low, and then low, high, low, like that. So we take these files from a Tata Memorial Hospital in Mumbai. I will just show this particular file. E like that. Three parts are there: low, high, low. So some files are there. Okay, so there are multiple such sorts of files are there. Okay, so I will just try to put, see this, I am having this Om files also, so Om chantings are also there. Try to generate some sorts of frequency analysis for these files also. Okay, so let's do over here. We will create a string and path. We go to string and path. We select a file path control. Just select this. This is a file path. Okay, now any file that you want to download, you can download it. So suppose this is a piano music, soft piano. Okay, so let me download this file then. Yeah, it's being downloaded. So see that here, a soft piano music, okay, is being downloaded. And where to find this? In downloads. The big file is there. Okay, so now this is the one file. It's in the downloads. I give it a path. Okay, it's in my downloads. Soft piano music. I have given its path. Okay, press Ctrl E. A path is given. Just connect this path to this. See that I'm, apart from a text file and Excel file, now I'm showing how to read and write an image and an image and a sound file. So this file path I have given. Now position mode, offset mode. I am not that much specialist in the voice analysis. So data. Now right side you see there is a data. This data I want. I will plot it. I will plot it on a graph waveform chart. Okay, these data are there. I have to plot it over there. So this is the data I have put. Okay, do you want to play it? That's also an option. So see, it will read to this particular path, take a data and amplitude versus time. See here, it's a waveform chart. Amplitude versus time will be plotted on this waveform chart. Okay, now next. Over here, I want to play this sound. So then go to graphics and sound and select, go to sound, graphics and sound and select an output. अभी तक हम क्या करते हैं, graphics and sound में files पे थे. Okay, now here, but here I can select a graphics and sound output. Okay, now select this play waveform output. Play waveform, play waveform. So you can test your device. It will ask whether your speaker is working properly or not. Just test device, some beep will appear. Yeah, so my speakers are working fine. Okay, we can play the waveform. The only thing it requires is the data. Okay, device by default is a 1. So your computer speakers as a by default, if you press a constant, create a constant, so 0. So device ID is 0. If you double click it, just double click it. See the headphone, I'm using a headphone and its speaker has a by default an ID of 0. Okay, suppose you are having an external speakers or you're connecting to a Bluetooth speaker, then ID can change. But here by default, this device ID is 0. Okay, press OK. I'll give this data. Now this data is given. Press Ctrl E. The only doubt I am having in this program is the soft piano music is a 2-minute long. So whether it's too big for this to play, but let's see, we have other smaller files also. Let's run this program. Yeah, it's being played successfully. The file was very big, so no problem. But you see that at the start itself, the Labview takes its amplitude versus time characteristic and plotted it. Okay, so this was a 2-minute file, 2 minutes 16 seconds. But and the moment you press the run button, automatically all this data is being plotted in one instance. So this is the advantage that you don't want to have. So see this particular thing, we can use our inbuilt speakers. Okay, so there's no point as such. There's no need to play this waveform, but just to make sure this is the same waveform, we can see that I have plotted it and I have seen this thing. Okay, now you can do a lot of operations with this. Now once you get this amplitude versus time characteristics, okay, so then there's so many options. So like just because I run this program again, then again I have to wait for 2 minutes. So I'm deleting this wire. Okay, I'm deleting this because I don't want to play it. Now I already got an amplitude versus time. Now let's see, do some signal processing operations. Okay, so what sort of signal processing operation we can do? Well, like we can have a power spectrum density, okay, or an FFT. Go right click, go to signal processing. This is a signal processing. In this signal processing, we can go to signal measure, waveform measure. Okay, so in the go to signal processing, in signal processing, select a waveform measure, and in this waveform measure, we can select an FFT and power spectrum. So last time we used this FFT and power spectrum. Okay, So I selected this FFT in power spectrum over here. Okay, this was FFT in power spectrum. Let's see its property. It requires some time signal. Okay, and it gives you a power spectrum PSD. Okay, that's what I'm interested in. Connect this. It's connected. Now at the right, power spectrum or PSD. Just move your cursor to this pink color terminal. Right click, create an indicator. Automatically, it will make a graph. Ah, it's created as an indicator. Just wait. So yeah, so right click over here. Okay, go to create. There's no graph. Okay, no graph indicator. Okay, so we have to create it from the top. Here I go select a graph. Select a graph. Once you select a V-form graph, just put it over here. Write down your FFT, fast Fourier transform. So for those who don't know a fast Fourier transform, for a time domain signal, if you want to change it to a frequency domain, we do a fast Fourier transform. Okay, so this is an FFT. Convert to an FFT. Now FFT is connected. See, very, very simple. There's a sound read file. We give a path. We download any sound file. .wav file को download करो, path दो. Okay, उसको V-form chart पे plot करो. FFT का block से connect करो. FFT के लिए एक V-form graph create करो. Press Ctrl E. Now it won't play for 2 minutes because I have removed that play waveform, but that icon. I have completely removed that. Now run it. See that we got an FFT. Okay, this is an FFT. Okay, so soft piano music for 2 minutes 16 seconds. You see these peaks. So now what does actually this is a frequency. I can change it to a frequency. Okay, so you can see that there are frequency component at 100, some frequency component at around 250, and some frequency component near 700, 800 region. Okay, so most the dominant frequency components are near 100. 90, 80, 90, 100. These are the most dominant. You want to explore this most dominant component? So select 100. See that these peaks are there. Okay. So this shows the amplitude versus frequency. So at 60 hertz, we have a maximum amplitude. Let's make it 120, 130. Now we are having a very reduced intensity. Let's make it 200. Make it a 500. So like this, we can see, and then there are certain components at 800 also. You see, we start getting a certain frequency components at 800. So at this frequency, I am having a this much amplitude. It's a power spectral density or an FFT. Okay, power spectral density or an FFT. Okay, next. What more we can do? Can I find an histogram of this? Okay, let's try that. Go to probability and statistics. Okay, so right click, go to mathematics. In the mathematics, select a probability and statistics. So आपको signal processing के ठीक ऊपर mathematics मिलेगा. Mathematics में you go to third row, probability and statistics. In probability and statistics, select a last element. Last element is histogram. I am explaining again. Go to mathematics, go to probability and statistics, and probably last is a histogram. Select this. Okay, so it shows a histogram window. Okay, no problem. You select this. Okay. Create a histogram. It needs a signal, and a histogram will be done. Give it this a signal. We give a signal and a histogram. Right click. Create a graph indicator. See that here we can have graph, or you can create a waveform graph at front panel. or you can do one thing, histogram के पास right click कीजिए, go to create a graph indicator. That's it. So one histogram is also created. Now we need to do some space management. Okay, so this is the histogram. Now, what does histogram do? Histogram shows us the deviation of a data from its mean position. You see, there's a bin 0, the data centered around this 0 is considered as a good. The more deviation is there, that's the bad sort of the data is there. Okay, then run this. I got an histogram for this particular audio file. Okay, so it's being centered around minus 0.5 to plus 0.5 over here. So now we have played an audio file. We read an audio file, then we played an FFT, played with the histogram. Okay, so there are so many such options. Now, next thing, can you can we change some orientation? So I need a certain very small file, not a big file for this. Just wait, I will show one demo. Maybe 5-10 seconds files is fine for me. 3 seconds, 6 seconds, 9 seconds, 12 seconds, 19 seconds. Let's see this. Looks good. I will download this file. No, so I was able to download this sample file. It's at 20 seconds. Okay, so now I want to do something with this particular file. Okay, now go to our music. Now, what one thing we can do? Suppose there's a file. It starts from t equal to 0 second to t equal to 20 second. We can create an array for this particular file, and then we can reverse that array, and then the file will be played in a reverse manner. Like it will start from t equal to 20, and then it will end at t equal to 0. So let's try to do that. Go to array. Okay. Now in this array, we can do a lot of stuffs here. Index array, replace array, build an array. Just wait. I required, see, this particular file has amplitude versus time. Okay, so I want to have a amplitude versus time data. Amplitude separate, a data separate. Okay, so for this, just wait. I will try to do this. Okay, so let's move to block diagram. Let's control E. Okay, so till plotting is going to be the same. There's no change once we plot it. Now, one thing we can do. Let's wait. Yeah, speaker testing is done now. Okay, so we need to consider its index array. Okay, so once we have an index array, then it is a easier option for us. Okay, so now I right click, go to arrays, select an index array. Okay, just select this index array. What does index array will do? See, this index array basically gives an element or sub array. Okay, so element or sub array is given by this particular index array. So this thing we connect from here. Okay, now automatically an element or sub array will be given for this. So this vform graph will be converted to an array. Okay, now next part, I will try to reverse this array. Okay, so how to do that? So see that, right click, go to vform. In the vform, there is a build vform. Is it correct? No, we have to find out get vform components. Get vform components. Okay, so you go to vform and select a get vform component. So put it over here. Get vform components. Okay, once you get this vform components, you connect the vform. Oh, it's not accepting, just wait. Output should be here. The element output is here. Yeah, now it will accept. Okay, so this is a get vform command. Just stretch it from below. Okay, so it shows the y and attributes. Okay, so it shows you a y and attributes. So y means amplitude, sound का जो amplitude है, और attributes यहाँ पे आपको क्या चाहिए? So it's you want a t0, you want a dt, you want a y. Okay, I want a dt. So y और delta t की terms में किसी भी waveform को आपने यहाँ से connect किया. Okay, so आप y amplitude और dt की terms में उसे find out कर सकते हैं. Okay, so I think till this point is not a big deal. You can do. Okay, now next, what more we can do? Press Ctrl E. Sorry, press Ctrl E, and now we require a reverse 1D array. Reverse array. Is it a reverse array? Somewhere we can find a reverse array. Yeah, reverse 1D array. Okay, some operation is there, reverse 1D array. So I put it over here. A reverse 1D array. Now, what does a reverse 1D array do? It takes an array and it reverses them. So that's what I want. Now, the question is, I have a amplitude versus time plot. This is amplitude versus time plot. Time, amplitude is different and time is different. The time starts from 0 to 20. Okay, 0 to 20 is the time. We have a 20-second file. Now I want to reverse it. So my time should start from 20. It should end up till 0. And amplitude should be changed now. Okay, यानी जो 20 पे जो amplitude था वो मुझे अभी 1 पे मिलना चाहिए. जो 19 पे था वो मुझे 2 पे मिलना चाहिए. Something like that. Okay, so what we do? Yeah. Connect the y over here. Y is connected. Okay, so reverse y now I obtain. So y at t equal to 0 now will be obtained at y equal to t equal to 20. Y at t equal to 2 will be obtained at y t equal to 19 or 18, like that. So reverse y array is obtained. In dt I want same. So I have a reverse y array and time is same. So right click and again go to vform. Now we have to build a vform. Okay, so now we need to build a vform. We have now able to build a vform. Just stretch it below. Attributes, type a dt. Okay, so अभी ये चीज आसान है. रिवर्स एरे y को y से कनेक्ट कर दीजिए. So देखो ये पूरा उल्टा है. गेट vform कंपोनेंट यानी किसी vform है उसका y और टाइम सेपरेट कर दो. ओके, कोई सा भी vform है उसका आप y और t सेपरेट कर दीजिए. फिर y को रिवर्स कर दीजिए 1D एरे. फिर एक vform बनाना है जिसका y और t अवेलेबल है और उससे vform बनाना है. दैट्स अ बिल्ड vform. सो व्हाट आई विल डू, आई विल जस्ट कनेक्ट dt टू dt. सो टाइम मुझे सेम रखना है, बस y एरे मुझे रिवर्स करना है. So something that is played at the start now should be played at the last. Okay, so this is done. Now whatever a vform is there, let's plot it. Right click, create indicator I have to make now. So this is the, let's separate it out. This is a vform chart. One more vform chart I will put. Let's say it. Reverse vform. Let's control E. Connect it. Done. Okay, so this program is done now. Now, because the file is just 20 seconds, we can play it. I can take a 2 play sound here. Right click, go to graphics and sound file, go to sound, select an output, play waveform. One play waveform. Test device. Yes, working fine. Okay, so where I will like to play it, I will like to play it over here. ये हमारा पहले बार play होगा. Okay, just stretch it a little bit. Okay, second, go to graphics and sound, go to sound, go to output, select a play waveform sound, press it. Okay. इसको डेटा चाहिए तो अभी डेटा हम रिवर्स वेवफॉर्म कैसे देंगे. इसे भी डेटा दिया. ओके, अब इसे नीचे से स्ट्रेच करेंगे. देखिए हम क्या चाहते हैं कि पहले नो आई विल गिव अ पाथ. ओके, दैट पाथ विल बी प्लॉटेड एंड प्लेड. Amplitude versus time will be plotted and we will hear some sound. After that, a reverse file is generation. A reverse file is generated and then that reverse file will be played. But here in this case, both will be played simultaneously. Play waveform 1 and play waveform 2. If you want to put it in serial, you have to adopt a concept of serial input, serial output. So for that, the error out of first play waveform should be given to error in of second play waveform. So now automatically this becomes a serial one. Okay, so I hope you got my point, that like this we can control. Okay, so first error out and second error in. Okay, now this is done. Press Control E, but I want to change the file now. We'll put it to the different colors. Because recently we have just uploaded one file, sample 15 second, I think this one. Yeah. Okay, so this is done. Now let's run this program. So this is the one sample file. There's one FFT. This is one histogram. Run this. So first you are listening is what the original sound, 19 seconds. Now it's a reverse. Now whatever you are listening is a reverse. Okay. So first 20 seconds, it was a straightforward music. And second, next 20 seconds, it was a reverse music. So what you are listening, the blue one is a original music. The yellow one is your reverse music. Okay. So now we have successfully reversed a sound file. Okay. So I was able to read one sound file. I perform a certain operations. Now you see, this is the here. You got an FFT, you got an histogram. Okay. And now one more thing, if I want to do, one sound file is created. Now this sound file I want to write, because I have created one sound file. This is my creation. I wanted to write it. So then we can write a music file. So I can go to graphics and sound files. Okay. Here we did a simple read. Now we can do a simple write. I go here, do a simple write. Now I need to give a file path. So this is required now. So here I give right click, visible items, label. I want to write this reverse file. Okay. So here I do some space management. Yeah. This is a path. I can simply create a file, add it, copy, edit, paste. This is a part 2. Okay. Now here, see that sample 15.wav file was there. So I don't know how to create a sound file. So I can, just like a browsing option, I have explained, right click on this, right click on the part 2, go to browse option and select here new or existing. क्योंकि अभी हमें नई फाइल बनानी है जो एग्जिस्ट नहीं करती है. ओके, जो फाइल एग्जिस्ट नहीं करती. अभी ये वर्ड फाइल और एक्सेल फाइल तो ऐसा तो नहीं हो सकता कि कोई ब्लैंक फाइल है और उसके अंदर डेटा डाल दिया. We have to create a new file. So we do a new or existing, press OK. I just change the number. So I do, here's a sample 15 second. I will write it as a reverse sample 15 second. Okay, reverse sample 15 second dot wave. So remember that sample 15 second is our original file. Reverse sample 15 second is our reverse file that will be saved in the downloads. Okay, users Arpit downloads. Okay, press Ctrl E. Now data we have already given. Somewhere here it requires a path. Where is the path? Part 2 is there. I can give this sound file a path. Okay. Now it requires a data. Data we can take from this reverse waveform. Why it's not taking any data? It's 2 terminals of a different type. Okay. Just wait. Yeah, so we need to make a build array. Okay. Yeah. So because see that this is an array of y entity, reverse y entity, I will create a build array. Go to array, select a build array. just select a build array, take a data from this element. It has a build an array, this array. Okay, this is a build array, and we can give this data to here. Yeah, start. Okay, so हमने क्या किया यहाँ पे देखिए, पहले जो vform चार्ट था ओरिजिनल, ओके यहाँ पर जो vform चार्ट था, एक ओरिजिनल vform चार्ट था, जब इसको एम्पलीट्यूड और टाइम में हमें चेंज करना पड़ा तो वी मेक एन इंडेक्स एरे। ओके, इंडेक्स एरे से इसके एक एक इंडेक्स का हमने डेटा लिया, इंडेक्स 0, इंडेक्स 1, इंडेक्स 2, लाइक दैट, डिफरेंट इंडेक्सिंग डेटा वी गॉट एम्पलीट्यूड वर्सेस टाइम। देन y के लिए हमने रिवर्स वाइड 1D एरे बनाया, dt हमने एज इट इज लिखा। फिर फर्स्ट पार्ट में हमने vform को y और टाइम में चेंज किया, एम्पलीट्यूड वर्सेस टाइम। सेकेंड पार्ट में हमने रिवर्स y और टाइम को से एक vform बनाया। ओके, आफ्टर दैट वी पुट अ बिल्ड एरे, and build array is connected to write to this sound file. Okay, a path is given, or in this path what we did, right click, browsing option, new or existing. Okay, so let's run this, clear this chart, clear this chart, clear this graph. Okay, now run this program. Now the reverse operation is going on. Okay. Now let's see whether we were able to write to a sound file in my downloads. So I can go to a downloads. Somewhere it has to be there. Oh, which file path I can just wait. Downloads reverse sample 15, just wait. Yeah, see that reverse sample 15 second is being created. The complete reverse file. Okay, so this was, I was able to write a sound file. Okay, I was able to create a new sound file based on my data operation. Okay, so this program I consider it's a very important, because not necessarily we can always play with an Excel or a data files, text files. We can play with the sound files also. We can actually play that waveform, like you can using a speaker of a desktop or a laptop. We can reverse this operation. We can perform a signal processing operations like an FFT, power spectral density, histogram related stuff. We can, and then the new file, whatever reverse sample file you created, that you can actually plot it. Okay, so it has a multiple options available. Just to give you a brief idea, I do a lot of biomedical signal processing. So in that I take a lot of data related to cancer, paralysis. So because it is found that any disease, any sort of disease, most of time, like it's a 90% chance, more than 90% diseases are there that enters to your body from your throat. Okay, and before we get some symptoms of any disease, it's our voice that gets affected first. So in order to have a pre-diagnosis or pre-prediction of any sort of disease in its early stage, the best way of having an analysis is analyze the voice. Once you do an voice analysis, you will get to know that a person is actually having a symptoms of that disease. The symptoms appears on our body, maybe in months, maybe in years. The cancer is a very dangerous thing, because normally we get a symptoms when it's already moved to some advanced state. So we try to collect the data from some various biostatistics databases around the world, Stanford, Oxford, MIT. Okay, and from there we obtain a lot of disease related data. So patients were asked to just speak a certain sorts of volumes, like vowels, A, E, I, O, U. In Hindi or Marathi, we call it a swar, or A, E, like that. So then, because without this swar or vowels, the speech has no pitch. If your speech has some pitch, some sharpness, because there are certain vowels or these words are present. So we try to have patients and healthy subjects and unhealthy test subjects. We have a recording of these vowels, and then we play them and we analyze them. So just one simple I can show here. Just I can. Yeah, so some sound files are there. Let's say this 1416. Okay. Because it will also get reversed, so I have to change the name now. Okay, so this is the which sequence I have to check. Yeah. So let's run this. Yeah, always it shows some problem. Yeah, no problem. Yeah, so see that this was the sound file that is being generated for the cancer. Okay, now because this I played with the reverse one also. So this reverse file is generated, and see that FFT. See that FFT completely distorted. See, this initially when we see a piano file, we were seeing a one peak only, one peak at a one frequency interval. But see, in terms of cancer, so many multiple and complete scattered frequency pattern. It's a time versus amplitude versus time on the left hand side, and it is amplitude versus frequency on the right hand side. So if I just fill it to the base, you see that a complete scattered pattern we can obtain. So like there are so many frequency components that are traveling with a one peak. So actually the sound peak is only one, because a person speaks A, okay, and this A can be around this 20 hertz only, but we get a pattern from 10 to 40 hertz. Just one vowel speaking, and it has a complete spread up pattern. So then we do a lot of signal processing and try to obtain this analysis. This voice analysis is important in telemedicine also. If you are from a medical electronics field, so there's a branch called as a telemedicine. In telemedicine, the doctors give the patients healthcare remotely. So in a rural hospitals, they don't have that many manpower, that many resources. So just take up voice samples of the patient and forward it to an urban hospital. So telemedicine is one such field. Apart from that, if you're a communication engineer, then we do the communication in terms of text, image, voice, video. So a voice message you want to transfer from one channel to another, from one point of channel to another. So then you need to have a proper plotting of this data. So what I do, I take data from the speaker, I plot it amplitude versus time, take an array, and I just trigger an LED or a laser, and that Boolean array is being created that triggers my LED laser. The light passes to an optical fiber channel, and we get on the receiver. Okay, there are multiple ways also, so I will just like to explain. Just wait. Uh, yeah, so this particular program I was talking about. So see that this is a sound card related experiment. So this actually, so like it takes a, because now I'm using my headphone, I have my mic. So whatever I am speaking, that Fourier transform will be plotted on this spectrogram. Okay, so it is called as STFT, short time Fourier transform. Okay, because whatever I am speaking is not a periodic function, it's a aperiodic, non-periodic thing. So whatever I speak is a non-periodic. So we take a small windows. So you already know the wavelet analysis and a windowing technique. And that a small sample of your signal is taken, and that's a completely do a sweeping of complete signal. So from one point to the towards the end, and whatever we speak is being plotted. So just like now I'm speaking, so amplitude versus time will be plotted, and at the same time, the Fourier transform FFT will be plotted because it's a aperiodic signal. So now this FFT will be in terms of colors. This is an intensity plot. Okay, so in the first, like a second day, third day session, I have shown about charts and graphs, intensity charts and intensity graph. Just see this program. Hello, 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 hello. Okay, so whatever I am speaking is being plotted now. Okay, and you can see there are certain colors in the intensity plot. When my volume is very high, so you can see certain colors. If I stop this particular program, see that if I try to stop here and I put it 1K, just to see this time. Okay, so these colors, because it's a rainbow pattern. Okay, rainbow pattern. So a blue color, because rainbow has a red at high and blue at low. It starts with violet, na? Web cure. So wherever you find a red, it's very high. Where you find a blue, it's very low. Okay, let's put it 0. See that here we got some intensity pattern. So now see, hello, 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 hello. Yes, so whatever I'm speaking is now you are getting some STFT. Okay, short-term Fourier transform. It is called as a spectrogram of my voice signal. So on the top you are seeing as amplitude versus time. So here I have exactly shown you how to plot amplitude versus time. In that we are reading from a sound file, but this time the data is real time. And at the bottom, what you are seeing is the intensity plot for my voice signal. So suppose I put something, I just hit my desk, see that these colors are increasing towards red. So there is endless possibilities for this particular programming language. Okay, and you can create a lot of things. You can use either a mic of your headphone, or you can use a speaker of your PC for the voice analysis. So this second session, as such, we dedicated on a hardware interfacing, but I keep it more simple because there is a lot of hardware in your PC and desktop itself. You have your microphones, okay, your mics, your speakers, Excel files, okay, Microsoft Excel, Word file, text files. So I wanted to use the available hardware that's available in your desktop or laptop, and we do a certain sort of signal processing. So normally this Excel, plotting to an Excel, reading from an Excel, plotting to a text, like writing to a text and reading to a text, reading from a text is very easy. The challenge happens when you deal with this sound, voice, image. Image is also not that problematic. because once you have an image, it's nothing like a real time. Video processing is also challenging, but I find the sound and video is a very, very challenging. But in LabVIEW, it becomes very, very easy. Okay, so I think it's time. It's already, yeah, 3:51. We have 10 more minutes. So any doubts or any queries are there for today's session, I would like to answer. This is going to be my last session because day after tomorrow, there's a scientist officer from TFR, Mr. Shriman Kumar. He's going to give you more exploration about the embedded systems. So then he is a master in embedded systems. So in TFR, he has interface not less than 200 equipments with the LabVIEW. So he will explain more hardware related programming, but more or less the fundamental things I have tried to capture today. Okay, so any doubt or any issue, I'm open to answer that. Over to you, Nikhil sir.
Okay, sir. Thank you, sir. Sir, like here in signal processing,
Yes, sir.
suppose we are going to apply auto correlation, cross correlation.
Yes,
So
sir.
is there any specific tool for that?
Sir, we are having an auto correlation and cross correlation toolkit.
Okay.
So, just like an FFT, you go here in signal processing. In signal processing, signal operations. Yeah, so in
Yes.
signal operation, there is a auto correlation and cross correlation. So
Okay.
auto correlation means you require you have a same set of data and you
Yes,
auto
sir.
correlate it. Cross correlation because two different signals are there and you do cross correlation. You would try to find a similarity between two. So these two options are there and we can use it.
Okay, sir.
Yes, sir.
Thank you, sir.
Yeah.
Participant, do you have any doubt?
Hello. Hello.
Yes, sir. Devin, sir. You are
Hello.
not audible properly.
Okay. Am I audible?
Yes, sir. You are
Yes.
audible. Please.
Arpi sir, can we integrate PLC with the LabVIEW like external hardware?
Yes, sir. We can integrate the PLCs with the LabVIEW. The PLCs normally are operated in a programming environment called as SCADA. Okay.
Yeah.
So like PLCs are very heavy in terms of the amount of voltage generation and the tasks they perform. So it's not possible to have a very a high level PLCs with the LabVIEW. But if we have a proper data acquisition device like that is being used with the PLCs, so we can integrate our LabVIEW drivers and we can do. So yeah, it's possible, but PLCs are programming environments are a bit expensive. So National Instruments provides a PLC programming environment in LabVIEW also, but provided that we need to purchase, we need to have those licensed hardwares also. So normally it happens that there's Allen Bradley, there are different sorts of programming environments are available. But now LabVIEW has entered in this field and they said that if you want to use a LabVIEW for the PLC, you need to purchase a NI product.
Okay, sir. And is there any limitation for file processing, like any content we want or large data? Then any.
Sir, there is no limit, sir, because today I generated a data in a while loop and it runs endless number of times. So there's no limit as such, sir. We can have a because I'm telling it with my experience that we used to take a data overnight. We used to run the program in the evening and then next morning we report to the lab and try to check how
Okay.
much data we have generated. So
But
there's
for-
such no limit, sir.
Okay, but for that we required purchase license.
Purchase license like Excel and those things no sir, there's no need for a you can have a data with this evaluation version also.
Okay.
It performs the same, no change.
Okay.
Yeah.
Thank you, sir.
Yeah, thanks, sir. Yeah, so any more doubts?
Okay. Thank you, Arpit, sir.
Yeah, thank you.
Okay. Now here we end the meeting. If anyone having no doubt. Sukruti ma'am.
Yes, sir. Yes, sir.
can
We
we-
can. Yes,
Okay.
we can end the meeting.
Okay. Thank you.
Okay, thank you, sir.